So, good morning friends. So now we'll be having the laboratory experiment number 5. Reduction of sample size by quartering method and determination of specific gravity, water absorption, moisture content, and densities of fine aggregates. So for our objectives, to determine the specific gravity, water absorption, moisture content, and densities of a sample of fine aggregates, and the testing sizes by quartering method. Also, to be able to discuss the results derived from the data collected in the experiment.
So for our materials, we're going to use fine aggregates, rectangular containers, absorbent cloth, and sieve number 4. And for our equipments, we're going to use flat edge shovel, mixing plate, digital weighing balance, and grinder.
So first, we're going to record the mass of all the 6 rectangular containers that will be used in the experiment. Ito yung B1 ka?
The next step is to place the samples on a hard, clean, level surface. Mix the sample thoroughly. After mixing, shovel the entire sample into a pile, then flatten the pile uniformly by pressing down with a shovel.
Go, 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 go! Wala, mas fine lagi na siya, bay.
Next, divide the flattened pile into 4 approximately equal quarters with a shovel. Remove 2 diagonally opposite quarters, including all fine material, and clean the cleared spaces. Repeat the procedure until the desired sample size of 1 kilogram of fine aggregates is achieved. Then sieve the sample using sieve number 4 and place the sieve samples into 6 rectangular sample containers. May hangin pero hindi siya dilinit. One kilo na yun.
Kilo kailangan?
1 kilo. Siyempre okay na. Puno na siya. Wag ka nag... Pang 6.
Ay, 1.10.
Pang 6 or pang... The next step is to divide the samples into 2. Saturate the first 3 samples with water, making sure the sand is drenched. Remove any excess water. Then leave the other 3 samples to dry. Put the dry and wet samples in the drying oven for 24 hours. After oven drying, record the weight of the samples as the weight of an oven-dried specimen in the air. W5, 1.34.
Mana na, sir, nangyalax ka.
Ayaw siya iparang.
Go.
So after oven drying, record the weight of the samples as the weight of an oven dry specimen in the air. So next, cool the samples for 1 to 3 hours at room temperature. So after cooling, separate the before wet and dry samples. Set aside the dry sample, and for the wet sample, wash it until the water is clear. Then immerse it in water and leave it at room temperature for 15 to 19 hours.
So now we're gonna take out the samples out from the oven dry.
Hello friends, so now we have here the dry sample and the wet sample. So for the dry sample, we're going to leave it aside, and for the wet sample, we're going to wash it until the water is clear. After that, we're going to immerse it in water, and then we're going to leave it in room temperature for 15 to 19 hours. Go!
Ha? Hindi yung mas. Labi na kung style. Labi na pag-ara pa lang niya para ako ng tubig. Ang very clear.
Henry. Akala ko ni pag water is clear ba? So here is our sample with clear water. Now we're going to drain it to transfer it into this container. Now we're going to wash the second sample. Now our second sample is ready for
Transferring to the next container.
So here we go. Now here is our third sample with the clear water. So we're now going to, the sample is now ready for transfer.
Okay naman, hindi.
After immersing it in the water for 15 to 19 hours, we will now be getting it from the water and spread it in the thin pan. sample 4. So now let's proceed to the sample 5. So here is our first wet sample and our second wet sample. So now we're going to proceed with our third wet sample. So here is our wet sample ready for oven drying for 24 hours. So let's put it in the oven dryer.
Next, calibrate the rectangular container by filling it with water to the calibration line. Record its weight as the mass of the container filled with water. Get a larger container and put the rectangular container with water inside. Fill the rectangular container with water and SSD sand to 90% of the container. Then tap the container gently to ensure junk air is eliminated.
Go.
Stop.
Fill the sand to 90%. Fill the water to 90%.
Libog na the instruction kay pero most likely ani kay ang
So hello everyone, so now we are going to transfer these samples into the tin pans and then weigh them, and then we're going to oven dry them for 24 hours. So let's go! Let's go! Tap method. Tap the samples for 24 hours. Materials and testing good eh. Banana cake. Yun na masyado kang Alex. Fried ice cream. Fried. Nga na ba yung ginagamit mo? Hello guys, so it's been 24 hours and now we're going to get our oven drying samples. Say hi guys. Table 1 displays the masses of empty containers consisting of 2 containers weighing 100 grams each and 4 containers weighing 80 grams each. The table also includes the combined masses of the specimens and containers, which range from 1,080 grams to 1,340 grams. Additionally, it provides the masses of the specimens pre-wetting and after wetting, which vary from 980 grams to 1,000 grams. Table 2 provides information or data on bulk specific gravity, bulk saturated surface dry, apparent specific gravity, and absorption. The saturated dry specimen masses range from 1,140 grams to 1,220 grams, while the container masses containing specimen and water vary from 800 grams to 1,000 grams. Table 3 displays significant variations in bulk specific gravity, such as 1.724 grams to 2.777 grams, and bulk saturated surface dry values of 2.103 grams to 3.167 grams, indicating possible differences in fine aggregate or probable errors in the experiment. Furthermore, the observed relative density values such as 2.777 grams to 5.555 grams suggest variations in density among the fine aggregates. The absorption percentage values of 14% to 22% suggests potential measurement error or increased aggregate porosity. The moisture content remains constant in trial 1 and trial 2 of 2.041%, but increases in trial 3 of 4.167%, indicating a higher potential for moisture retention compared to trial 1 and trial 2. The specific gravity and density values offer crucial information on the stability, strength, and durability of aggregates in building applications.